Let me welcome you all once again. Yes, and we work together. We make little more efforts to understand our things. Okay, and today what we plan to do is we are still in the process of we are trying to understand the construction of higher energy states Fock states and QFTs and string theories right, and we have been taking examples from the harmonic oscillator, bosonic real scalar field theory, complex scalar field theory, and fermionic oscillator and Dirac. Spinor field theory, and then the bosonic string theory, and then we eventually go to the superstring theory. My main point is that we can always find a common thread, the common concepts that apply right from the simplest case of the one-dimensional harmonic oscillator in quantum mechanics, let us say fermionic oscillator in quantum mechanics, and then different examples, different kinds of field theories like the real scalar field theories, complex scalar field theories, Dirac spinor field theories, bosonic string theories, and superstring theories. Everywhere, in all the cases, you write down some Lagrangian, some action, you use the variational principle, and you derive the equations of motion, right? And in all these cases, we find that these equations of motion, they are some partial differential equations, and they are wave equations of the theory, right? In these wave equations, there are very nice features that we know from the theory of partial differential equations, for example, that we know from ordinary elementary mechanics, for example. You can always represent the solution as a sum of the waves that move to the left and the waves that move to the right. So you call them left movers and right movers. Okay? And you also know from the theory of partial differential equations that the most general solutions could always be expanded in the Fourier modes. Okay? we could expand them in the Fourier modes. So these modes, often for short called as modes, they are nothing but the annihilation and creation operators that we have seen everywhere in mechanics, quantum mechanics, in quantum field theory, when we quantize the theory, right? So the three important things that we encounter everywhere is A of K, A dagger of K, and A dagger of K, A of K, which we define as N of K, which is the number operator of the theory, right? These A's and A daggers and these number operators, they would be bosonic if you are considering a bosonic theory, right? So you are considering bosonic variables, bosonic fields, okay? And this goes all the way to, let us say, bosonic string theory or simply string theories, where you talk in terms of the, so here, for example, the polyatomic action, you can obtain without going into the details. Right now, we go according to a certain theme. We want to understand that the occurrence or the need of these objects called the annihilation and creation operators or the Fourier modes. We have seen that in harmonic oscillator we can expand X as a linear sum of A and A dagger. Okay, and once you do that, then it's enough that you can construct everything else about the theory, except that you also postulate or you define that this so this also you define, okay? I think rest of the properties they automatically fall. So for example, here for the one dimensional harmonic oscillator, you could expand X as some constant times A and A dagger. I may not remember the plus and minus signs that should appear there. So X is some constant times A plus A dagger. And this, of course, you again define that N and if you were considering, so here also you can find maybe some constant, no, only. So you can see for the harmonic oscillator, you can find out the equation of motion just from the Lagrangian. Now, if I do that for the real scalar field theory, you can phi of x mu equals to 0. You know, the Klein-Gordon equation is the field equation that you obtain by the variation of the action for the real scalar field theory. In the context of complex scalar field theory, you would have one more equation, m square times phi star or phi dagger, as you like. If you like, you can write it like that. So what you have here is that you expand phi of x some constant. Let me ignore the constants. So let me not even say this equals to, you can write some constant times a of k e to the power minus ikx plus a dagger of k e to the power plus ikx. And if you have, so this would be the Fourier decomposition or the Fock space decomposition for the real scalar field. Okay, and if you want to consider a complex theory, complex scalar field theory, then this would also be constant a of k plus, now you will have, so this would still be phi. Let me write only b dagger, then v of, or am I creating too much mess? Let me be more careful. So for however, so this is for a real scalar field theory. Okay, if I have a complex scalar field theory,